Katrina here, and I want to welcome all of you to the realm of multivariable calculus. So we're going to start looking at problems that have more than one independent variable. And in particular, today we're going to dive into partial derivatives. So in my previous videos, we learned how to solve derivatives in single variable calculus, and now we're going to look at multivariable situations. So first off, I want to have us consider some region. So we're going to say that this new multivariable function, f of x and y, is defined in a neighborhood around some point x0 and y0. So we're going to consider this whole neighborhood here that exists around our point x0, y0, which is in the center. So if we consider this, we can now look at the definition for partial derivatives. So partial derivatives in Leibniz notation are written as this df over dx of x0 and y0, and that equals to f sub x of x0, y0. So this just tells us that we're taking the partial derivative of f with respect to x at some point specified, x0 and y0. And this over here is an alternative notation that indicates the first partial derivative. So we have our f, and then we have this sub x. So similarly, we can have this definition for the partial derivative with respect to y. So that is going to give us the partial derivative of f with respect to y at x0, y0 equals to f sub y of x0 and y0. Again, so this is the partial derivative of f with respect to y at a given point x0, y0. So you might be asking at this point, well, what is a partial derivative? Well, pretty much computing the partial derivative reduces to computing a usual derivative by treating either x or y as a constant. So that means when we go about and look for the derivative of the function, if we're calculating this one over here with respect to x, then that means we're going to treat y as a constant. So y will be constant. And then in parallel, if we're looking at this partial derivative over here with respect to y, then that means we're just going to treat x as a constant. And then all our other rules for finding the derivative will still apply. So let's do an example so I can show you just how easy it is to calculate partial derivatives. So for example, let's consider our multivariable function f of x and y equals to x plus 2y cubed all squared. So this right away should be screaming chain rule to you because we see that it has this exponent over here. So I'm going to show you how we can still use our derivative rule, chain rule, even in a partial derivative setting. So first of all, we want to find the partial derivative of f with respect to x first. So what does that mean? That means we have to treat y as a constant. And then we just solve the derivative accordingly. So let's go through this. We're going to be applying the chain rule. So we bring the 2 down. We keep everything in the middle. So we have x plus 2y cubed. And then now we want to take the partial derivative of the second portion with respect to x. So we have x plus 2y cubed, right? So that's the only difference here. So now let's go ahead and let's calculate this portion over here. So again, we want to be treating y as the constant. So what is the derivative of a constant? Well, that is just simply 0. So that means that this portion over here is just going to be equal to 1, and that's it, because the derivative of x equals to 1 and the derivative of 2y cubed equals to 0. So that means that our final answer is simply 2 multiplied by x plus 2y cubed. And that was it. Now let's try doing the same question, but instead of differentiating with respect to x, we're going to differentiate with respect to y. So now we have df of xy with respect to y. So again, we're going to be applying chain rule. So we take the 2 down. So we have 2 multiplied by x plus 3y cubed. But now we want to take the partial derivative of the inside part with respect to y. So we have x plus 2y cubed. And now let's do that again. Let's calculate this partial derivative. So again, x is being treated as a constant. We know the derivative of a constant equals to 0. And then now we're going to use power law to calculate this derivative for 2y cubed. So we're going to have 0 plus 6y squared. So now if we put this all together, our final answer is going to be 2x plus 3y cubed multiplied by 6y squared. And we can simplify this by combining our terms. So we've got 12y squared multiplied by x plus 3y cubed. And there you have it. We've calculated the partial derivative of our function with respect to y by treating x as a constant. If you enjoyed this video, please drop a like and comment any questions that you have. And subscribe for more fun and easy to follow math videos. I look forward to seeing you next time.